I've called it part 2 just because there was already a part 1 kind of. Anyway, where were we? We were here. So we've seen a few things in the list. We know how to kind of manipulate a few things. We definitely, with the indexing is important with lists, because if you have a list, you would definitely like to access the elements of the list, right? You can go through each element if you like. You can choose elements if you like. We learned also about slicing. Let me do list. Let me do nested list first, and then I'll go on to do a kind of a small program that will allow you to learn a few other functions and methods of lists that I'm interested in. So this is not the end. Like, we've only done one function length. The other things were just normal. Okay, so what is a nested list? A nested list is what it is, a list within a list. So if you would like to, and nothing stops you, you could go something like this. Maybe you could keep the names of the students here. Add names of my students, but whatever it is. And maybe create, so that's my first list. And maybe just create some number, or you can create as many lists as you like. It doesn't say that, oh, you can only have one list inside the other or whatever. You can do whatever. So maybe like these are my grades in my 3 assignments. Who knows? Right? So you could do something like this. And again, don't have to be strings. So I could say, oh, I got 9 marks in my first assignment out of 10. I got 8, and then I again got a 9. I'm doing myself good, right? And there is a nested list. So a list can contain a list or lists also. There is no end to it, right? So nested lists to any level. Now, when you have nested lists, how will you access the elements? So if I try to do something like this, print, and I say, give me my, so now there is a list inside a list. So if I'm going to say nested list and only give one position, like 1, like something like this. Oh, not 1, so sorry, 0. What should it return? The first list, because my first element is a list again. 9, 8, and 9 is what I'll get back. If I say I want to see my, if I want to see my second element, so this is your first element, which is a list. That's what you should expect, right? So the first element, which is a list, it will print 989 as a list. If I say show me my second element, which is a normal element, that's what it will print. Let's try it. Am I missing brackets anywhere? We will know in a minute. No. And look at the last output. So the first element is a list, so I get it, 989. My second element was an element, I get Anju. You had a third, which was a list. Again, the third would be a list, right? So indexing is still working as it should. But now comes the question, what if I want to access an element inside my first list? So I have a list inside a list and I want to access it. So how do you access elements in the nested list? And again, nesting can go to whatever level. You can have as many lists as you want inside a list. There is no restriction. So let's try it again. Let's say something like first element in the nested list is, yeah, you can always say off, right? Let me try to show it to you. The first element of, I'll take this nested list 1. Sorry, nested list 0. That's my first element. Is, and I want to show it. And this is how I show it. So you are interested in the first element of this list. Just add another parameter to it. There, you use 2 dimensions. You use 2 square brackets. Makes sense? Because it's a list and there is a list inside it. So the first 0 says which element of the nested list. And then in there, which element are you interested in? So I'm just saying first, you can use second, you can use whatever. But the concept, but the idea here is to let you know that that's how you do it. So let's look at that one now. And run it. Uh-oh, something is wrong. What did we call it? What did I forget? What was the error? F5? Invalid syntax. Comma, thank you. Comma was missing, right? Comma was missing. There it is. So the first element, which is a list, is 989. How do you access the second element? Normally, same index value. But if you want to access an element inside a list of a list, then you have to use two parameters. One for the outer one for the inner one. Which makes me believe that I could even have a list and the second element could be a list again. Do you want to try it? I don't know. Like it's not so tough, I think. So let's take it again. And let's change this, the second one, into a list again. Like nothing stops me from changing it. Oh, why did I put them in quotes? Strange, right? I was expecting, quotes just means there are non-numeric data, but these were marks. Nothing bad in it, but it just makes me uncomfortable. So I'll make my second list a list again. I'm hoping it will be fine. It's just a list inside a list. I think I can even do this. It doesn't seem as if I can do it. What will you need? You will need 3 parameters. So let's try it. Let's try to print. Let's try to print. Let's try to print the second element of the nested list 0 is. So that's the second element, which is again a list. Right? I should have 1 and 2. Let's try it. There it works, right? So you can nest it to any level. You can add, and then again and again. So if you want to look at the first element, so if I say, second element of this, oh, so we'll just have to, oh God. Second element of this, comma, of this is, what do I want to do? I want to add a third element, a third reference for 1. Okay, so what am I going to say? Second element of this list, 1, 2, of this list, the whole list, 1, like of the whole list is, so 0, 1, 1 should show me 2. Let's see if it works. Like logically, I don't know why it wouldn't, but who knows? There it is. So the second element of 1, 2 of this list is 2. Right? So you can nest it to any level. And you can have more than one list, nested lists also. Nothing stops you from doing this. This is nesting to any level, but you can also have nested lists, more than one nested list. So I only had 1. You could have more than 1. That's allowed, right? And then I've also done this. I've also said nesting to second level. Just so that you know, right? And therefore, the list is very powerful in Python. It is. Like I haven't seen it in any other language, to be very truthful. Okay, now let me kind of introduce you to something that is kind of not as if you can't learn it, but you should have an idea. So I'm not going to make an interactive program. I'm going to take some marks of my students from you or whoever the user is, and then maybe find the average and so on and so forth and go on, right? To make my program kind of interactive, I'm going to take a variable called confirm. And while this confirm, so I'm sticking to still a y. In the assignment, you're definitely going to see something like exit. And it's not tough. By now, you should know. So if the confirm is y or it is a y, a capital Y. Why don't I try it? And maybe that will give you an idea. If there is a function called upper. Okay, so it hasn't changed purple. Is there a function called lower? No, hasn't changed color. So there should be something. Even I haven't looked it up, to be very truthful. Okay, so while we confirm, while you are saying, yes, I want to go on, it will go on. So what am I doing here is I'm going to input the marks of a student in one assignment, in any assignment. So maybe if I want to repeat it for another assignment, repeat it for another assignment, and so on. So therefore, I'm putting a interactive loop. So what I'm going to say is I'm going to input marks for an assignment for some students. Okay, so I'm going to kind of say, okay, input a mark, and then you can stop at whatever. We'll stop at -1 because that's one good way of kind of doing it. Okay, so I'm going to use an empty list. So I'm going to create an empty list to start with. Okay, that's my empty list to start with. This is which I'll populate. Have I?
Just remember, to get it so it's either uppercase or lowercase, you'd be like confirm dot lower.
Ah, so it's a method.
Yeah.
Okay, so confirm dot lower and then is equal to whatever. Okay, not a bad idea. Let's do it here so that it's a method.
Yeah.
Okay, like that. Okay. Thank you. Okay, now this is something that you haven't seen before. Like you've never seen this dot notation, especially students who are doing programming for the first time. We've used functions before. I've just called them length or string or input or print. I've just called them. Here is a notation which is actually coming from the object-oriented world. It's basically object name dot the method name. Now, what is this method? What is this new word or new terminology we are using, method? Just let me explain what led to it. When programming started, everything was automated and programmers wrote programs as they thought, like do this first, do this, do this, do this. So these were called this was called procedural programming. You thought these are the procedures I want to do, these are the functions I want to do. And if you needed some code to be repeated, you put it in a function and the program could use it. Perfectly good, perfectly fine. Now, when more and more programs were written, the need was felt, oh, the code that I had written in program 1, if I could reuse it, it would be good. So I could copy and paste. That was one solution. Copy it from there, paste it here, and make some changes, and it would do. The other option was to kind of create common functions and put it in the library so that everybody could use it. That was also good. So they're kind of going step by step, things were improving. Then came this concept that human beings think of the world in terms of entities, objects. For example, if I say car, all of you know what a car is. You can think of a car as a car. And with the car, you also associate its functionality. You can drive a car, you can stop a car, turn left, turn right, reverse. Whenever I say something like coffee, something comes to your mind. You exactly kind of think, oh, coffee. You know its characteristics, how it looks, and you know what you do with it. You drink coffee, or if you really don't like it, you throw it, which you shouldn't. But anyway, you can share a coffee. So there is, I say a chair, again, a picture comes in your mind. You know how it looks and what can you do with it. So since human beings thought that way, and we've been always thinking that way, the paradigm of programming shifted from procedural programming to object-oriented programming. Object-oriented programming said that I will define a program to be the object, what you're talking about, the entity like car, and all that is associated, all functionality, which is called methods of the car together, and give it a definition. So that's what became. So instead of writing procedural programming, which was application, you're writing an application, what started happening was classes were created and each class defined an entity with its functionality and gave it a name. So if somebody has defined car, you can say, oh, can you give me a photocopy of that car so that I can use? So the paradigm shifted from procedural programming languages to object-oriented. And the object-oriented was just a different way of packaging. Nothing changed. You still have those three pillars: sequencing, decision-making statements, and iterative statements. But how you packaged them changed. So what was the package? A class was defined, which was a program. It was still a program, but the class was defined in such a way that the data of the entity and the methods or the functionality were put together and given a name. And this is an example of an object called confirm. Confirm is what? A string. And I'm saying string dot the functionality. And what is the functionality? Lower. So what am I saying? Take a string, convert it into lower, and then compare it with small y. So even if you enter a capital Y, it will convert it into lower and always compare it with small y. So it doesn't matter what you enter, small y or capital Y, it will convert it into lower and then do it. So this notation of object name, which is confirm in my case, which is of type string, dot the name of the method, is object-oriented notation of using functions. So old functions became methods, and methods were associated with objects. An object is what? A photocopy of a class. Okay? Yeah.
I just realized that made you do a syntax error. So the way that the lower works in this case is after you do confirm equals y,
yeah.
Next line it should be confirm equals confirm dot lower. Actually,
oh, you have to save it somewhere? Yeah. Okay. Okay. So you take a confirm and then, I mean, though it's a little odd,
yeah,
but it's a, yeah.
Confirm dot lower,
because I think strings are immutable.
Yeah. So
yeah.
The way its behavior is.
That's what behavior is. Okay. So we'll talk about that too.
Lower, then you just, while confirm. Or you don't have to do the semicolon in this language.
Oh God.
I know. I like.
Yeah, it's just. Okay, now let me tell you what I did. Why did I take the confirm, convert it into lower, and put it back in confirm? Now strings are immutable. You cannot change strings. So confirm is a string. I put y into it. Confirm is a string. In Python and in all languages, actually, almost all languages, strings are immutable. You cannot change them in place. So if I have a place and I have y inside it and say, oh, now change it to capital Y, I can do it. I'll have to take that string, change it, and put it in another place. And that another place could have the same name. So the old confirm place is lost and the new confirm place is given. But strings are immutable in nature. We call them immutable. Whereas lists are mutable. Mutable means you can add something to it, you can remove something from it, and it all happens in place. So you don't have to worry about it. But strings by their nature are immutable. You cannot change them in place. So what do you do? If you can't change something in place, what do? You make a copy of it and keep it somewhere else. You've changed it, right? So here what did I do? I took confirm to be y. I used the method lower on it. I changed its value. And then instead of creating a new location is created, but that new location is also called confirm. So the old box is lost, right? So that's why I have to use it this way, because of how strings behave. And strings are immutable in nature. They cannot be changed in place. If you have to change it, you have to make a copy. You have to change it and then put it somewhere else. And I, just so that I didn't want to give it a new name, I said use the same box. So in a way, behind the scenes, it's not the same box. It was moved to a new location. That new location was again called confirm, and the old location is lost. Okay, so that's why we have to kind of do it this way. So if it is not very clear, but I'll write it for you, that strings are immutable, it's called, cannot be changed in place. What did I do? I kind of copied it somewhere, right? But you'll say, oh, but you gave it the same name. Yeah, you don't have to worry about it. The copying was done and it was put in another place. Okay. Right. So now what I have to do, all I have to do is I have always to compare with y. So when you give it to me again, at the end of the while, somewhere I'll ask you again. Do you want to give another list? So let's write it right here. So I'll take the confirm again from you. I'll take the confirm again from you. I'll say, do you wish to continue? For another assignment. So this will come somewhere at the end, right? But I'm just writing it. And I'll say, give me a Y or a Y. Doesn't matter what you give me. I asked the user, I said, do you wish to enter marks for another assignment? Y or Y, any other character to stop, right? So I'm asking the user. This will be asked sometime, somewhere at the end. And then what do? I again do the same thing. I convert it into lower. So that if you give me a capital Y, it is converted into a lower y. If you give me a small y, it is again converted into a small y. But the idea is that always I've saved myself checking the two ors. I don't have to write it twice. I only write it once. Right? I only write it once. So this extra work is just taking your answer and converting it into lowercase. So taking the answer and converting to lower case. Hopefully it will work. I'm not sure. I'm just taking Ian's word for it, but I think I believe him. He must have checked. Okay. So if I don't get a syntax error, I should be good. Let's just try an F5. I haven't done anything, but I don't get a syntax error. So it says, do you wish to enter the marks for another assignment? So it's kind of gone through it. Any other character to stop. So let me enter a capital Y just for the heck of it. I'll still continue because I've converted into lower. If I give anything else, really doesn't matter. Anything else, no is usually, if it's a Y, then we think it's a no, it will stop. Right? So how you use the method, you have to kind of look it up, which Ian did for me, thanks, and just kind of use it. So this is an example of a method. So the functions and methods are not different in their functionality. A function also does something, has a name, takes parameters, returns a value. A method also does the same thing, does a job, takes parameters, returns a value, but just they have been called differently. We call them functions in procedural programming languages, and we call them methods in object-oriented programming languages, because methods are associated with an object, right? That's why they just changed the terminology. So now what was the advantage? The advantage was this. If a class was defined for car, you knew that it will have the definition of the car, the color, whatever, how it looks, and the functionality. What can I do with the car? So how I look, what can I do has been given. Much easier to work with, right? So instead of collecting bits and bytes from here and there, oh, give me this function or give me this function, they kind of said, why don't we put the definition together? How I look and what can I do? Okay. Okay, so now let's do this. This was what I was kind of coming at. What I'm going to do is I'm going to take a mark from the user. I'm going to use a function because we've learned function. Right? So I'm assuming I'm going to call a function. What will the function do? We'll think about it when the time comes. We don't know. So we start with an empty list. I'll use some print statements to make it pretty. So that you know what's happening. Right, so I'll call a function. We'll write the function, but the aim of the function will be the function will return me a mark. And there will be some stopping condition. So I'll say while my mark is not equal to -1. So the stopping condition will be -1. So we'll write it. Don't worry about it. The input mark is a function which will do a job. That's okay. So I keep taking marks. I get the mark, and while the mark is not equal to 1, how will I add it to my list? I will take my list and call the method append. There is a method called append. There is a method called insert. There is a method called delete. There is a method called remove. So what does append do? Adds it at the end of the list. What does insert do? You can say, oh, I want to insert at position 0, at position 5, at position 7. So that's the difference. But methods exist. You'll say, how will I know about it? The manual will tell you, right? So now, if it is a written exam, now I'm not saying what I'm giving you, but even in your assignments, if you would like to know that where to look, just so that you know, in Python, manuals have been downloaded also on your local machine when you downloaded Python. You can go here. You can go to something like list. For example, I was searching list yesterday. Topics will come up. You can kind of go and look for, I don't know, built-in types, data structures, or something like string built-in functions. There are some built-in functions or some built-in methods or whatever, and then double click on it. And you will see a list of all the built-in functions for a list. Similarly, if I was looking for methods, let's say list methods here. So here are the list methods, but I don't see anything that will help me. These are built-in functions. If I can find out, okay, let's try to, I know a method called append. Let's look for append, and maybe from append I can. It's not very helpful, is it? The built-in functions was easy, but methods, I don't see methods coming up quickly. Arrays and so on, logging handlers, built-in functions. That's really odd. Like when we were looking for string, if I say methods, let's see, if I only say methods, what happens? Not very helpful. Built-in types it is coming up with. What's new? What's new? No, I'm not interested in that. You should have just come up with list methods. Is there something here that will help me? No, there are examples of all the functions. Let's go to built-in types. No, that's not what it is. API reference. Strange. Classes? No, classes is not what I'm interested in. But these are the classes in Python, I think. Strange that it's not giving me list methods. Match similar words, search previous or search titles only. Maybe search titles only. Let's see if that helps. Or maybe list topics. No topics found. Okay. No topics found. Okay, so that's not a good way of going. Search titles only. It should give me a whole set, and then I can kind of see, oh, this is what is available. Changelog, built-in types, API reference, unit test, data model, data structures, what's new, Python documentation. Strange, right? It would be so easy if it could, I could just show you the whole list. I mean, I can go to the that is really strange. Your search topics are really bad. Seems like. Let's see if this will help. List append. Not very useful. That's bad. Not much help. Like they're showing the built-in types and the built-in functions. If they could just show me the built-in methods, it would be so nice. Oh well, standard library. Okay, I don't want to look at the standard library. I want to look at the list. Okay, let me just put list. Let's see what happens with list. Same thing. Oh well, I was here yesterday and I was looking for methods and they did come up, but now I can't remember. How did they come up or what did I give? I saw a whole list of their methods. Importing modules, XML documentation. Oh well, I don't want to waste time right now. But in the manual, you should be able to find them. Or of course, you can Google them. Okay, so marks.append will simply take what you give it and add it to the end of the list. There is another method called insert, which inserts at a position. There is a method called delete, which deletes an element. Remove removes another element. The difference between delete and remove, delete will delete at a position, remove will remove an element like Anju, if I say remove Anju. So there are list methods that are available. I'm just using one, which is a very simple one, which is basically the append. And ask again, ask for another mark. Now the question is, what does this input mark function does? What does it do? So let's write that function input mark, right? So as again, because I like to write my functions at the head, I'll go up here and I'll define my function here. I'll define a function called input mark, which is not taking any input from me. But what does it do? It asks for a value from the user. Let's do this, right? I'm going to create two constants. And again, constants in Python are defined in all uppercase, but there is no reserved word constant with it. What is a constant? A constant is a value that does not change in your code. But I kind of fail to no reserved word is being put by it. Mostly languages will put const in front of it. But here, I mean, this is just a convention that put them in all caps and separate them by underscore. But how does the program know it is a constant? I've yet to kind of find out in Python. But what I did find out in Python was you could put it in a Python file.py, all your constants, and you could import it. But then somewhere in the file, how will you say it's a constant and I cannot change its value? So I'm still figuring it out. As soon as I know, by next week, I'll tell you. But what is a constant and how is it different from a variable? A variable means varying values. The values inside that box can change. What is a constant? The value inside this box cannot change during the execution of your program. Why do we give it a name? Why can't I use 0 and 100 in my code? 1 for readability, makes more sense. Minimum mark is 0, maximum mark is 100, right? 2, flexibility. If I want to change my maximum mark from 10 to 100, I only do it at one place. I don't have to go and look in my code. Oh, where did I use that magic number 10? So do not use magic numbers in your code. Never. Always give them, if it is a constant, like you're using pi. If you've done math, 3.14, right? If you're using a constant whose value will never change ever, and you don't want it to be changed in your code, use it as a constant. Give it a name. Name gives it more meaning, but that's only for readability. But name also gives it flexibility. Of course, you won't change pi ever, but think about tax. Tax can change from 13% to 15% to 17% or to whatever. But you've called it tax, you give it a value, and then in your code, you use tax everywhere. That way, you don't have to bother. If it changes from 15 to 17, you go to its definition, and then you change it. But what I've read is that usually the practice in Python is to put all the constants in a py file and then import that py file so that all your constants are in that particular file, right? So you just import that particular module as it is called. I haven't done that because I only need 2, but in a bigger, larger application where you have a lot of constants, the best way is to put it in a module, all your constants, and then import that particular module, like you do import random. But I still fail to understand that how do I say, oh, it's a constant, nobody can change it. I couldn't find a solution. I kind of Googled it yesterday, looked at different things, but still not done it. Anyway, let's define the function. So this is just showing you that I have defined 2 global constants. Why did I make them global? Because I've said don't use global variables if you can avoid it. Every function must be localized, must be independent and do a job. Then why am I doing it? I'm doing this because constants never change. So there is nothing to be lost. And 2, since it is a constant and it may be needed at many places in many functions or in the main body also, then I don't have to worry about, oh, somebody will change it, because it cannot be changed. A constant cannot be changed in code. But what I fail to understand right now is that there is no reserved word constant in front of it or whatever. So how does the compiler or the interpreter know that it is a constant? So maybe the practice of putting it in a separate file and then the user cannot see it and cannot change it is how it goes. But I still am lost with it. Okay, so bear with me till I find out what should I do.
It is like that. So apparently Python doesn't have constants.
Yeah, there is no constant declaration.
Don't change it.
You just don't change it. I couldn't find it. There was nothing. I couldn't put the word constant in front of it. Usually languages will do this.
Doesn't work.
Like usually some languages will do something like this and tell the compiler or the interpreter you can change it. You can't change it. Like it's a rule. But I couldn't find anything in Python.
Yeah, because it doesn't have anything. Apparently just like you make everything caps lock to display it.
Yeah.
And then you just don't change it again.
But that's really strange. It's a variable then, right?
Yeah, it's just a regular variable you wouldn't caps.
Yeah, and then the only extra thing that I kind of read about it was put it in a different, like put it in a file or put all constants that you need in a file and then import it so that they're kind of out of sight and out of change. But that doesn't even help, right?
No,
it doesn't help.
So you're just loading variables.
Yeah, you're just loading variables. So I couldn't find it and I was lost. I mean, I did go through so many sites yesterday to find out. Ian says, cannot do it. And apparently you can't. I didn't find an answer, right? So we will assume that min mark and max marks are named constants, though I can change them in Python, okay? So I'm going to define a function and notice how I'll use it. So all these small things are useful in programming. You will have to learn, you'll kind of recognize them. And if you do more programming ever in your life, these will come back. It will make more sense, right? Right now, you're learning Python more from a scripting point of view, like writing small scripts that will help you do this, right? Okay, so I'm going to define my function. What does this function do? It takes an input from the user and kind of says, okay, we'll check that it should be between 0 and 10. So instead of saying 0 and 10, I'll use those constants. And I'll also allow the user to give me a -1 because I need -1 to stop it. Okay, so let's do that. Let's take a mark variable. This mark is local, guys. This mark has nothing to do with the global mark. Now I'm trying to make it the same variable, but don't get confused. This is a local mark, okay? I'm going to ask for input from the user. And I'm going to convert it into a float because marks can be float. Oops. So marks can be float. I'm completing my bracket so that I don't forget, okay? And I'll give a message to the user. I'll say, please enter a mark between, and now you have to remember something in input that I found yesterday. Input only takes one argument. So you can't put commas here. You have to put pluses here because you're concatenating. You're creating one argument. If you put commas, it means number of arguments, right? Like in print, I could put commas and it takes any number of arguments. But input only takes a argument. And because I want to give a message and kind of, I don't want to say 0 here. I want to use that min mark here. So I'm going to break it. I'll use the min mark here. What is the sense if you don't use it? And then again, use a plus. So please enter a mark between, let's say, let's not use between because then it's confusion. Are they included? Please enter a mark this through. Through means it will be included, okay? So you'll have to put your own brackets and blanks and whatever. And I'll show the max mark. What message will come on the screen? The message that will come on the screen will say, please enter a mark 0 through 10. If you change the 0, 10 to 10, 20, it will say through 10 to 20. If you change it to whatever, it will just give you your message, right? Now, and we'll do this. Oh, and we are in input. So we'll have to change this into a string too. So sometimes you just have to use the plus concatenation. There is no other way. Right? And we will also enter, we will also say, please enter -1 to quit. So put a plus. And I learned something else, I think. I think taking it and going to the next line. Yeah, okay. So the continuation character, if I want to write in a line and kind of, it's a big message and I want you to see it, you can continue it like this. So I am saying, please enter a mark between this through this. To exit, enter -1. So I'll put, where was it, plus. I'll put a full stop. To quit or to exit or to whatever. To stop, enter -1. Okay. So hopefully I won't have a syntax error. No, I haven't seen a syntax error. Okay, so now you can break up your sentences. I'm just breaking it up because it was kind of long. So you can break up your sentences and then it doesn't matter where you start. This is actually continuation. Okay, it's not breaking, it's continuation. So indentation doesn't matter when you are continuing. So I'm saying please enter a mark 0 through 10 is what it will replace it with. Period. To stop, enter -1. Okay, now let's go back and we'll have to now match it here. Okay, so how do I now say? How do I've given this message on the screen. And now my loop. While my mark is not equal to -1. Keep on asking. Because I can stop at -1. Or my mark is less than, what was that? Min mark. Or greater than. Notice I've already used that mid mark and max mark 4 times already. So it's readability. I don't see magic numbers 0, 10 everywhere in my code. I see min mark and max mark, and they tell me min mark is 0, max mark is 10. So I'm saying while mark is not equal to -1, or your mark is less than 0, or it is greater than 10. I've put my or condition in brackets. I don't have to because and has a higher priority, but this kind of makes it more clear to you as to what I'm doing. So what I'm doing, if you give me a -1, I'll stop. Or if you give me a mark between 0 to 10, I will stop. So while this is going on, keep on asking the user for the mark. Right? So while the mark is not equal to -1 or it is less than 0 and greater than 10, we'll print something. We'll print invalid mark. And you can also say, I can use the separator here and put it in the same line, but I'm just putting it in a different line because my message is long. And I'll say the mark is invalid. And then I'll again repeat this message for the user because maybe he was not paying attention. So I'm going to ask the mark again. Right? So what will happen? How does input mark work? It asks for a mark. It checks that it should lie between 0 to 10 through. Right? So therefore I've said if it is less than 0, don't do it. If it is more than 0, don't do it. Right? And real marks are allowed. So less than 0, -0.5 will not be taken. It's only from 0 to 10. Anything floating will be taken. But if you say -1, it will stop. Why? Because remember I put a stopping condition that's how I want to stop. Keep on asking the mark from the user and go on. And when you are done, return that mark to whoever called the function. That's the end of your definition. That is where your definition ends. So write your functions this way. Defining the function, define it, and then say end of definition of input marks. That will make it easy for you if you're writing more than one functions. Okay, your life will be much easier. You know where it starts, where it ends. So my input mark is defined. Make sense? So I didn't kind of think of anything. When I wrote my input mark, I wrote it as if I had no clue what else. I'm writing it as an independent function. Whoever can use it. So I'm saying I need no parameters. I will return you the mark. My condition is that the mark will be between 0 and 10. And you can again take this constant -1. You can remove it from here and you can give it another name here, stop mark or invalid mark or something. And then use stop mark everywhere. So you can do this. Let's call it, since we are using it, why not? Give it a value of -1. And notice what I can do. I can take that stop mark. I can use it here. And I can also use it in my code, in my main program. So is the input mark function clear? What does it do? Take a mark from the user, validates it. If it does not lie between 0 and 10, it asks again. That's what it does. And that's what you want to do. You want to enter a mark between 0 and 10. And it also stops if you give it a -1. Why that -1? Because here I kind of made that condition that keep on asking from the user while the mark is not equal to -1. I can use that constant again here. Right? So I've called it stop mark. So that's the use. One, readability. It improves readability. And two, flexibility. You'll say, what flexibility? It's only present at one place. I change my mind, I change it at one place. I don't find and replace it at 10 places. That's readability and flexibility. So named constants are recommended in all languages. Unfortunately, in Python, it doesn't make it a constant. Like in other languages, if I try to give it a new value, somewhere in my code, it will give me a syntax error. It will say, you can do that. You told me that it is a constant, but I can't do anything in Python. So we'll just kind of assume that anything written in all caps is a constant, though it's not, okay? So here you keep asking, and you have your mark, and you're appending it to your list. Your list is ready. Do you want to see the list just to be sure that it really worked? Let's do it. Why not? So let's start printing a few things so that you know that, yeah, oh, things are working. So let's print the output. Let's print the output, right? Okay, so the first job, I want to print the mark list. So you can print it as a list if you want, or remember you have the for loop and you can print it in a list if you want. Whatever you find needed. If there are 50 marks, putting them all together will kind of be a little odd. I have 50 students in my class. So it depends on whatever you want to do. It really is not a big thing, but I can make it whatever you like. So how many students? Let's say there are, so let's use that length function that we learned. There are, use the length on the marks. Student marks. So now I'm telling you that these are how many I have. There are these many student marks, or you can say there are these many students in class, or students who did the assignment. Whatever, really doesn't, as long as it is a neat and clean message. So that will come on the screen. There are these many students who did the marks. Okay, now next, if you would like to show the marks, your job is now to show the marks. But I must tell you this. In Python, no function can be called on an empty list. It comes up with an error, right? And logical. It's quite logical. The list is empty. You didn't give any mark. And now you're saying, oh, tell me what is the highest mark. Tell me what is the lowest mark. Print the list and so on. So I'll check if the list is empty. And how do you check that? As if you were checking anything else. You will use an if statement. So what will you do? You will say if the marks, if the length of the marks is equal to 0, that means the list is empty. Then I don't want to do anything. We'll say something like no marks were provided. Then you print a message. I don't know where it dances to instead of 4. Give a message like something which will make sense. No marks were provided or something. No student marks were entered. So notice I'm again using a while loop. I'm using a confirm. I've now shown you, thanks to Ian, I've shown you the lower method. So now you know if I was not using Y, I could have used yes and convert it into all lowercase, and then doesn't matter how you enter it. Whether you enter it in caps, whether you enter it as capital Y, ES, like any combination of yes, I'll convert it to lower and then I can just compare it with yes. Saves me writing all that, how many? 3C3, 3 factorial over 3 into 2, all that 6 combinations of 6. I'll say is convert it into lower and check against yes. Or convert it into all upper and check it against capital yes. So that way it doesn't matter how you enter your yes. Now you know that. No student marks were entered. So this is the message I give to the user. You didn't enter anything. Now how are you expecting me to do something for you? But if you did enter something, But if you did enter something, now let's do a little math. One, I want to show you the list. Here are the marks and so on and so forth, or whatever and whatever. So let's print it. I don't want to see this message if there are no marks. So I show it. I'm using a for loop just because, what's going on? Just because it just becomes neater. So for I in marks. What do you want to do? You want to print it out. This is irritating. Print the value of I. So here is the list of marks. I've printed it. Okay. So I've shown the output and I've printed it. Now I want to show a few more things. Strange that if there is an in-class assignment, students don't leave the class. But if there is no in-class assignment, slowly students will leave the class. Right? It's kind of odd. The process is that you learn something. But if that's what brings you to class, I'll write on Blackboard, there will be no in-class assignments and you can stop coming. But the purpose is that if you're paying for something and you want to learn something, that's how you should do it. But that is strange because people will especially ask me, is there an in-class assignment today? Why need I tell you at the beginning of the class if there is? But anyway, really odd. As students, our mentality was very different, but that's how it is now. Okay, so here is the list of marks and I show the marks. Now we can do quite a bit of things in it without even doing any code. There are so many functions. I can find the max of my mark, the min of my mark, the average of my, everything can be done. Let's try it here. Let's try it so that you can see it. So let me do some printings for you. Print, let's say, print the maximum mark in the class or in the assignment is, let's close it, let's do this. And as simple as this, use the max function. Don't reinvent the wheel. Believe me, no functions were available 3 decades back. And we had to write code ourselves to find the maximum in the list. But now it's in the library. Why would you do it? And especially you guys, I wouldn't even want you guys to kind of do it because it's an introductory course and you're learning Python from a different viewpoint. If it is available, use it. Why reinvent the wheel? You want to see the minimum mark? So this is a function. Notice when I use it, you should be able to say, oh, she's using a function because functions are not used with the dot operator. Use the min function. Do you want to see the average? How do you see the average? What's the average? You take the sum and you divide it by the total number of students. And you already have that. Remember, you have that count function. Sorry, the length function. I think there is a count also, if I'm not mistaken. There is a count method actually. Let me double check. I had a list of methods in... Yep, here. No, that's not the what it is. Oops. Okay, now we have to use length. I was thinking something else. There is a count method, but it doesn't behave this way. Its count is different. Here. In 3 simple lines, I can show you the max mark, the min mark, and the average in the class. Okay, let me see how many students got the maximum mark. So let's see. I'm going to say something like this. How many students got 10 out of 10, right? So how do I count? This is how you count. So you take your marks. There is a count method. Guys, please, I can hear you. Please talk softly. Count for the maximum mark. Look how many times did this occur in the list. See a use. Marks.count. So on the marks list, I'm using the count method to count how many times does 10 occur in the list. Why 10? Because my max mark is 10. Again, I don't have to bother. My max mark is defined. I don't have to use a magic number 10. So I'm saying these many students. So I'll put a comma. Then I'll start. Student could be one student or could be more than one students, scored full marks. Or you can say perfect marks. At a perfect score. And you can show what the perfect score is of, and again show the max mark. Neat, right? Shh, please, enough. You've been talking for a while. If you have to leave the class, I'm not asking you to stay in my class, but you don't talk in my class. It disturbs me and it disturbs my students. And I'm worried about students who are here to learn. They're important to me, right? Okay, so what did I do? I said these many students had a perfect score of, and it will say 10 or whatever. Notice the use of my constants, so-called constants, and there is no magic number in my code. The 0 is not a magic number. You'll say, oh, that's a magic number, but it's quite clear. Length is 0 means there are no elements in my list. So don't make everything a constant just because they are numbers, but don't use numbers out of the blue, which could make sense if you give them a name, like tax, minimum marks, maximum marks. And you can do this too. You can count how many people got a 0. We'll count the min mark here. And instead of saying a perfect score, we'll say had a score of 0. So it's up to you what you want to do, right? So there are functions that are available. There are methods that are available. I've only used 2 methods for now. I've used an append method. I've used a count method. And there are other methods. I'll show you. You can sort your list and show it. Sorting is always better for human eyes, right? A sorted list is always better for human eyes. So I'll show you some sorted lists also. Anything else that you would like to do? Like I've shown you the maximum, how many students got maximum, how many. You can use an if statement here. You can say if your score is between this and this, you got an A, else you got a B, else. Like you can do whatever you like. It's just coding, nothing else. You can make a chart. You can decide, oh, between 0 and 5, anything less than 50% is a fail, and anything more than 50% is a pass. You do that. It's not a big deal. What will you do? You'll put an if statement here. If, oops, let's take 50%. So the maximum mark plus minimum mark divided by 2. Okay, so let's take that. So if, oh, now this will take more time. It's in the for. Every student will either fail or pass, right? We'll do that afterwards. I'm just kind of short of time. And I can do it. I'll show it to you if I have time. No big deal. But I also want to show you some sorted lists. Let's print this list in sorted order. Let's print the list in ascending order. A list of marks. And I'll show you a few ways of doing it. There is a function that is available, and there is also and the name of the function is sorted, if I'm not mistaken. Oh, now again here, something that I have to kind of talk about. The function sorted returns a new sorted list, does not sort the list itself. So it returns, it doesn't sort the list itself, it returns a new one. So what I'm going to do is I'm going to call it, what did we call it? Marks. So I'll call it sorted marks. And I'll call the sorted function on marks. Why did I do this? I did this because sorted function returns a new list. So I had to do it. It does not sort it in place. It doesn't sort it in place. It returns it. So the list of marks in ascending order, and we'll kind of put a colon here so that you can see, and we'll say sorted marks here. Same kind of concept like in the lower, which was a method, but this function is just behaving that way. So you have to know, before you use a function, you have to know how it behaves. But there is also a method that is available, just so that you know. using a method. So this was using a function. Now I'm going to use a method. And the method is called, I don't know why my cursor is dancing all over the place. Let me save it. There is a method also, and notice the notation of the method will be just a little different, and it sorts in place. So you will take your marks and say dot sorted. Oops, what is it called? Sort. And it sorts in place. I didn't have to create a new one. It sorts in place. So the list of marks in ascending order is this. Now your list is sorted. It's sorted in place. You can prove it. Here, if you show marks, it won't be sorted. It will only be sorted marks. So sorted functions returns a new list. So you want to kind of confirm it, show marks, and it will be in its original order. Here, the list of marks in ascending order. After this, if you want to show marks, it has been sorted. And just because I'm doing it, you can actually also sort it in descending order. There is no function for it, but there is a method for it. And that method is called reverse, if I'm not mistaken. I could be wrong. No, I'm right. See? So there is a sorted method. There is a reverse method. The difference is these sort in place. So they basically, it was sorted. So marks was sorted in place. If you print marks out after this, it will show you the original. So just so that you know. Again, just so that you know what I'm saying is right. I'll say print and I'll say original. Original mark list does not change. And I'll show it to you. I'll kind of give a blank. I'll put a colon. I'll put this and I'll show you marks. You will see it is in the same order. And in this one, once I sort it, it will change. Therefore, I had to create a new list when I use the function. So you will see that, oh, it has changed. So which one should you use? Should you use the sorted function or should you use the sort method? Depends on you. Really no. If you want to sort it in place, use the method. If you want to keep the original but make a copy, use the function. See, so it depends on what you want to do. Okay, so this is just to show you, oh, things can be done with the list. And there is no end. There is no end in the sense that I can do more things with it. Like I have more methods with it. I've shown you count, I've shown you sort, reverse. Insert I haven't. We've done append, but you can insert. You can do remove if you like. You can do delete. So how will you know about all these methods? Search, right? I mean, you have to search and find them what they are. So if you have an idea that they exist, then you should be able to Google and look for more. Like upper, lower, I knew from different languages. They are still called upper and lower. It's just how I had to use them. Okay, so let's try this program now. Let's see how it works. Oh God, I forgot to print somewhere. To stop enter -1. Forgot my, there. End of line while scanning. Again, same thing. Copy and paste, right? Okay, we are only concentrating on the last part. So we are starting student mark entry. I'm going to give a -1. Oh, I didn't put a colon. I'm going to put a -1 and it's going to say, invalid mark has been entered. Okay, something is wrong in my logic. Okay, so let's see what's wrong in the logic. Oh, this is what is wrong in the logic. We need an and here. We need an and here, not an or. Or will work, it will definitely work. Or means one of the conditions is true and it will work. Okay, so to enter -1, we'll give a blank here, we'll give a blank here. That was untidy. This was wrong. There was a logical error. You use an and here because I want to make one of the conditions false, right? To get out. If you do an or, If the one of the conditions is true, I keep going on. So mark is not equal to -1 is, but I was giving a -1, so it was not equal. That was false, but inside there, it was fine, right? So there was a logical error. I mean, you have to kind of think about it. I wasn't thinking when I was typing, but that's no big deal. Okay, so let's enter a -1 and it should stop. Trace back, there is error. So there are 0 student marks. So there are no marks. That's right. No student marks were entered because I gave a message, right? Now I have a problem with max. It says a value error. It is an empty sequence, it says. Empty sequence. I did an else. I said if it is not equal to 0, then do it. Okay. Empty sequence means I can't do max on something. Therefore, I said if it is equal to 0, stop. Oh, indentation. All this printing has to be 1 tab ahead. All this printing has to be 1 tab ahead. Indentation is wrong. There. Oh, one more. Or maybe that's the right one. I'll just change this one. There. So the printing was, the indentation was wrong. After that, the sorted marks was just showing you sorting. Now, can you do, oh, you know what? You can't even do sorting on a empty list. So all this has to be also indented. So the functions are, I don't know about methods, but functions were not working on an empty list. There. So I said, if you have, let me indent once more. It's kind of looking a little odd. Better. Okay. So I said, if it is empty, then no student marks were entered. Right? Else, here is the list of marks. And this message is coming twice because I said there are 0 student marks. I mean, I showed it. Here is the list of marks. And then everything, all calling of functions. I'm not sure about methods, but definitely max does not work on an empty list. That's the error I was getting. I don't know if count will. I mean, you can try if methods also give you the same problem, but functions are not working. Let's try it again, and let's try it again. Okay, let's stop with a -1. Okay, so there are 0 student marks. No student marks were entered. Do you wish to enter marks for another assignment? Y or Y, any other character to stop. So I'll go Y. And again, we can put a kind of input somewhere so that it looks neater, right? Because it's coming in the output window. Okay, let's give some marks. Can I give a -0.5? No, it's invalid. Invalid mark has been input. Can I give an 11? No, because I have to stay between 0 and 10. Can I give a 0? Yes. Can I give a 4? Yes. Can I give a 5? Yes. And 9? Yes. A 10? Yes. Let's give a 0 again to see if 2 students got 0. I'm giving 3 10s. Can you repeat a mark? Of course you can. Can you give float marks? Yes, because I said, do you want to stop? Yes, let's stop. Now, I don't know what the answer will be, but average or whatever. And, oh God, oh God. Okay, so we did quite a bit of things after that, but let's go.
I thought maybe you created an infinite loop somewhere.
No, that's what I thought for a minute, but we've done a lot. Okay, here it is. Okay, let's look at it. Here are my answers. There are 10 student marks. Here is the list. Okay, so something is wrong in my list. It's only showing me 0, which was my first mark. Okay, so we know there is something wrong in my output. Okay, let's look at the maximum mark, 10. Minimum mark, 0. Average, 6.5, I'm assuming is right. 3 students got a 10. Yes. 2 students got a 0. Yes. Original mark list does not change. 0, 4, 5, 9, 10 does not change. The list in ascending order is 0, 0, 4, 5, 0 changes. List of marks in ascending order, none. So something is wrong. Something is going wrong here. Original mark list does change. List of marks in ascending order, none. So something is not right somewhere. Something is not right somewhere. Okay, so let's close this. Yes, I want to kill it. And let's see where are we going wrong. So the first thing was the printing. Oh, this is for I in marks, it prints it, and then it does this job as many number of times. Okay, so that's wrong. This printing has nothing to do with the for. Okay, so here, this has, Okay, so these are all the parts of else's. So they have to be de-indented. If you have something not working right, that means indentation is wrong. So format, detent. Okay, so one more. So we'll take this forward. We'll take this for forward and we'll take this print forward. Okay, so this has to be only done once. The printing has to be only done once. I was only seeing a 0. And then these answers have to be only shown once. But they were showing 10 times because my indentation was wrong, right? So all this is in the else part. And the printing of the marks is only in the for. And then now hopefully we should be okay. So I did the original mark, the list of marks, a list of marks in ascending order. Original mark does not change or will change, and the list of marks. Okay, let's try it once again. Okay, let's only concentrate on the bottom part. And we already know that -1 and all that is working. So I'll just give normal marks. 0, 4, 6.5, 7, a 10, another 0, a 10, a 5, a 6, 3.5, and a -1. Better, thank God. That was happening 10 times. That's why we saw so much. It was not an infinite loop, but it was a wrong loop. So there are 10 students in the class. Here is the list of marks, 0, 4, 6. Why is it showing with a 0.0? Because it's floating point. Remember, I said it's float. I appended floating numbers to it. The maximum is 10. The minimum is 0. Average mark is 5.2. I'm assuming it is right. I could be wrong, but looks right to me. 2 students had a perfect score of 10, and 2 students had a score of 0. Has space, we'll do it. The original mark list does not change when you use the sorted function. But of course, it gets sorted when you show the new list. Oh, I still have a none here. Why am I saying a none here? List of marks in ascending order. And the list of marks in descending order. Okay, do you wish to enter another one? No. So something is still wrong with my method call. Let's go back to the method call. What happened? Let's look what happened. So this is happening. This is working. But this is not working. Put your brains. I know it's 10:50. You can leave. But why is it not working?
Let's try make that mouse outside, and then when you bring with the mouse.
But do you think that will matter? But why? Logically, why? So what you are saying is I put the marks sort dot here outside and then just say marks. Maybe the call is causing, I don't know. It. Okay, I see your logic.
Marks equals marks dot sort.
No, you don't have to say marks equal marks dot sort because it sorts in place. So it does that in place.
But then that shouldn't matter then. If it's...
Yeah, then it shouldn't matter, right? That was my thinking. It shouldn't matter. Like logically, it shouldn't matter because I'm calling a call. I'm making a method call here. But from yours, from what you're saying, is this is, I mean, I can try, but if it works, I have to kind of think again as to why it is behaving this way. Okay, so let's go 1 and 2 and 3 and 4 and 5 and a -1. Yeah, it does. So 1, 2, 3, 4, 5, 0 students got 10, 0 students got 0, maximum was 5, minimum was 1. The average is right, and now it is showing the list. Original mark was, oh God, it was already in sorted order, so that didn't serve the purpose. But at least it's reversing, right? It's reversing. So I want to stop. You wish to enter no, and then I come down. But that's strange, right? Yeah, method calls can be made. I should have been able to make a method call right here, and it should have printed it. Maybe it's the behavior of the print that. Yeah, but when I say print and I'm calling the method should give a result back. It sorts in place, but maybe the method is not returned because the method is returning none. Therefore, it was saying none. It was doing its job. The method was returning none. When you call a method in a print statement, it shows you the return value. It was working. You're right. It was returning none. The sort method returns none. So it was showing none. It's showing you the return value. Yeah, and that's what it does when you call. Yeah, makes sense. Perfectly makes sense. Yep. Yep, it makes more sense now. The method, why did we see a none, guys? Why did we see a none there? The sorted method was returning none. Return none is the default value. So it was showing me here, that's your none. And it was right. The answer was right. The logic was wrong.
I'm surprised it wouldn't say like undefined or something.
No, the return value is none. See, when it does a function, and in any language, when you come to the end of the function, it doesn't return anything, right? Maybe it returns null, or I don't know. I've never tried it in Java. Maybe we should try to see what does it print if I print the return value. But here it is making sense because marks that this method returns none. So if you try to do it here, it will show you none, and that's what it was doing. So logically, it was wrong. So there, we did quite a bit of things in this. We haven't finished yet, but we did quite a bit of things. Right? So thanks for your patience. I'll put this on Blackboard for you guys.